Welcome students. So in this session we are going to see the band pass filter. So in our syllabus the last topic of third unit is band pass filter. So that is we are going to see today. Let us enter into video.
u.com
Recap. So in the last class we were studied right leg driven ECG amplifier. So that is used to measure the ECG without any common mode noise. Okay. So objective of today's session is to study the different types of bandpass filter. Okay. Right. First one, the basic recording system. Consider this is a basic recording system. The humans are connected by electrodes and lead wires. Electrodes or transducer. So the transducer or electrodes is connected with a signal conditioner circuit. The signal conditioner circuit is given to a writing system. Writing system means that displaying the waveform or storing the result. Okay, right. So the basic recording system has the following important parts. First one, the electrodes. Electrodes pick up the biological signal from the human body. Already we have studied the different types of electrode. So most of the ECG measurement we are using surface electrode. So surface electrode is very low cost. The foam bed electrode is very low cost and we can use and throw it away. Okay, one time use we can use. And the second one is a transducer. The transducer convert bioelectrical signal into usable electrical output. It convert one form of energy into another form of energy. After that, the signal conditioner. The signal conditioner convert the output of transducer into electrical quantity suitable for writing system. So the writing system may be a LCD display or oscilloscope or pen writer, etc. And the last one is writing system. Writing system provide a visible graphic representation of quantity of physiological signal. So if you are measuring ECG, the ECG signal is in the form of graphical representation in paper. So that is done by pen writer. Okay. Then functions of signal conditioner. So the signal conditioner do the following operations. First one, signal amplification. So the electrodes connected with the human body is connected to the signal conditioner circuit by using lead wires. So the signal conditioning circuit first amplify the received input signal. So the input signal in the range of millivolt or in microvolt, that voltage range is amplified to some volt. So this is a signal amplifier or pre-amplifier. After the amplification, it is perform filtering operation. The filtering operation allows some of the frequencies and block all other frequencies. So record frequency only passed to the next stage and the remaining unwanted frequencies are blocked, that is by a filter. So most of the high frequency noises are removed by using filters. Okay, then next we are going to see the type of filter. Actually we are having the four type of filter: high pass filter, low pass filter, band pass filter and band stop filter. See, these are the four type of filter. High pass filter just pass high frequency only. High frequency means that is some number. So the number is indicated by the cutoff frequency of high pass filter. The cutoff frequency is 1 kHz means then the high pass filter can pass more than 1 kHz and block less than 1 kHz. Similarly, low pass filter is pass low frequency only and reject all high frequency only. So which high frequency it will reject? For example, if in the cutoff frequency of low pass filter is 1 kHz, then it will reject more than 1 kHz and pass less than 1 kHz, so that it is called a low pass filter. And the band pass filter means band pass filter pass some particular band of frequencies. So it has two cutoff frequencies, higher cutoff frequency and a lower cutoff frequency. According to the requirement, we can change the cutoff frequency and we can design a filter for our requirement. Band stop filter is just opposite to band pass filter. So it stops the frequencies that is mentioned by the two cutoff frequency, that means higher cutoff frequency and lower cutoff frequency. Okay, here we are going to see band pass filter. So in our syllabus we must study the band pass filter in very detail. Okay, so by cascade connection of high pass filter and low pass filter makes band pass filter. So first we have to use high pass filter. After that we are connecting the low pass filter that gives the band pass filter, which allows the signal with specific frequency range of band and attenuate the signal with frequencies are outside of the band. So this type of filter is known as band pass filter. So band pass filter pass some range of frequencies and block the low frequencies less than lower cutoff frequency and block the frequencies higher than higher cutoff frequencies. So it has two cutoff frequencies. So less than lower cutoff frequency it will block all the signals, higher than higher cutoff frequency it will block all the signals. So that is called band pass filter. The band pass filter has two cutoff frequencies. The first cutoff frequency is from high pass filter. This will decide the high frequency limit of band, that is known as higher cutoff frequency FCH. The second cutoff frequency is from low pass filter. So this will decide the low frequency limit of band, and that is known as lower cutoff frequency, that is represented by FC low. See, this is a simple band pass filter circuit. The band pass filter circuit is based on RC passive components. So the resistor and the capacitor components create one simple RC band pass filter. So in the input side, first we face the high pass filter. C1 and R1 forms a high pass filter, and C2 R2 forms the low pass filter. So these two filters act as individual low pass and high pass filter, and it will produce a band pass filter. Sorry, here the input side you are having the high pass filter, and output side you are having the low pass filter. Okay, right. Next, the first half of the circuit diagram is passive RC high pass filter, and this filter will allow the signal which have frequencies higher than the lower cutoff frequency FC low and attenuate the signal which have frequencies lower than FC low. So lower cutoff frequency FC low equal to 1 divided by 2 by R1 C1. Similarly, the second half of the circuit diagram is passive RC low pass filter. This filter will allow the signal which have frequencies lower than the higher cutoff frequency FCH, and it will attenuate the signal which have the frequencies higher than this FCH. So FCH equal to 1 divided by 2 by R2 C2. Then the band or region of frequency in which the band pass filter allows the signal to pass, that is known as bandwidth. So the bandwidth is a difference between the higher and lower cutoff frequencies. Higher cutoff frequency and lower cutoff frequency is called as bandwidth. So the bandwidth means how many frequency the amplifier or the filter perform well. So that is indicated by the bandwidth. Okay. Next type of band pass filter. The bandpass filter is divided into two types, that is a active bandpass filter and a passive bandpass filter. First I want to see the active bandpass filter. The active bandpass filter is a cascade connection of high pass filter and a low pass filter in filter with amplifying component as shown in here. See, first the input is given to high pass filter, it will filter the high frequency component, and that signal is given to amplification. The amplifier is amplify the given input signal and it is transferred to low pass filter. Low pass filter just pass a low frequency component. So these are the active component. Why we are saying this is active means the amplifier is done by transistor circuit. The transistor is an active circuit, so that this circuit active is called as active bandpass filter. Then this is another one circuit diagram. So this diagram is an active bandpass filter divided into three stages: high pass filter, that is the input stage, then amplification, that is the middle stage, and low pass filter in the output stage. So these three components are combined together to form bandpass filter. Then passive component. The passive bandpass filter is done by resistor, capacitor and inductors. Therefore, the passive bandpass filter is also used to passive component and it does not use any operational amplifier for amplification, but the active bandpass filter use an operational amplifier for amplification. So like an active bandpass filter, the amplification part is not present in a passive bandpass filter. So passive bandpass filter having only high pass filter and low pass filter, there is no amplification present in passive bandpass filter. So this is a circuit diagram of passive bandpass filter. So initially input is connected with a high pass filter, then output is connected with a low pass filter. So the output is bandpass signal. This is a passive bandpass filter. Okay. Next I'm going to see the Q factor. A bandpass filter can be characteristics by its Q factor. The Q factor is reciprocal of the fractional bandwidth, that is a Q factor. A high Q factor will have narrow passband, lower Q factor have wide passband. These are separately referred as a narrow band and wideband filter. Next one we are going to see what is wideband filter. According to the size of bandwidth, it can be divided in wide band pass filter and narrow band pass filter. So the Q factor is less than 10, then the filter is known as wide pass filter. As the name suggests that the bandwidth is very wide for wide band pass filter. So here the Q factor is less than 10. Suppose the Q factor is greater than 10, that filter is called narrow band filter. It allows very narrow frequency to pass. It will reduce most of the high frequency noises. This is a frequency response of two type of filter, that is a bandpass filter. So that is between the wide bandpass filter, narrow bandpass filter. So the first diagram indicates the wide bandpass filter frequency response. The bandpass is mentioned at 3 dB. Then from the 3 dB we can find lower cutoff frequency FL. FL is a lower rate of frequency, here HL is a higher rate of frequency. So these two frequencies used to decide the band of the given filter. If the Q factor according to the Q factor, so the narrow band and wide band is changed. Okay, so this is a frequency response. What is frequency response? So the question onwards the answer is present, the response to frequency. So how the device respond to frequency, that is called as frequency response. If the device is operate well in all the frequencies, then that device is very good device. In some devices perform at some particular frequency only. Some other frequencies it won't perform, then that device is not suitable for all the frequencies. Then bandpass filter cutoff frequencies. The bandpass filter is a combination of a high pass filter and a low pass filter. The cutoff frequency is derived from the high pass filter and it is denoted as FCH. The filter allows the signal which has the frequencies more than FCH. The value of FCH is calculated from the following formula. So the FCH equal to 1 by 2 by R2C2. Similarly, the second cutoff frequency is derived from low pass filter is, and it is denoted as FC low. The filter allows the signal which has a frequencies lower than the FC low. So that is a low pass filter. So the value of FC low is calculated from the following formula, that is FC low equal to 1 divided by 2 by R1C1. So these are the formulas used to calculate the frequency. Next we are going to use to calculate the bandwidth of bandpass amplifier. The bandwidth is the difference between higher cutoff frequency and lower cutoff frequency. The cutoff frequency of high pass filter will define the lower value bandwidth, and the cutoff frequency of low pass filter will define the higher value of bandwidth. So bandwidth is, it's an important factor in the amplifier. So the all the frequencies are passed through the amplifier or the filter means that is wide bandwidth. Some particular frequency only passed means that is a narrow bandwidth. Okay, and finally we can see the applications of bandpass filter. So bandpass filter are widely used in audio amplifier circuits. For example, the speaker used to play only desired range of frequencies and ignore the rest of the frequencies. The best example is subwoofer. Subwoofer is a bandpass filter, so it produces some range of frequencies only. Then it is used in optics like laser, and these filters are used in communication system for choosing signal with particular bandwidth. It is used in audio processing. It is also used in optimize a signal to noise ratio in sensitivity of the receiver. So the bandpass filter is applied in all the area where we are using the signal. So in medical application also this filter is used to filter some high frequency noises in ECG measurement. Okay, right. So by this topic the unit 3 is completed by bandpass filter. Okay, bandpass filter is a very important question, so it's fully a theory question, some amount of equations only present, so student must watch this video till the end and you can take the notes. Okay, so thank you students, thank you so much, thanks for watching. Please share, subscribe and like. Thank you.